So I'm just going to kind of talk through how these theorems 3, 4, 5, 6, 7, and 8 lead up and led us to prove theorem 9, which is this one that we're really going to use in a useful way, and that's the one that says if I've got a line, I can basically pick any pair of points to name that line without changing it. So in theorem 3, we start off assuming an order, and we say, all right, if we have some order, then B is on the line from A to D and the line from A to C, and C is on the line, the segment from A to D and from B to D. And the next theorem uses this in a this is really a corollary. So a corollary is a really short, immediate result of a theorem. It's not a big theorem all by itself. It's just one little more step. And so this one little more step says if I've got 4 points that have an order, then they are collinear. So all of those points live on the same line. And so what's the line they live on? Well, they live on the line between A and D. And so the big part of this has already been proved, that B and C are on this line from A to D. And problem 2, if I remember correctly in the homework, asked you to prove that every end point of a segment is on the segment. So you can use that to say that A and D are on the line. So all of those points are on the segment from A to D, and so they're also on the line from A to D. So that's pretty good. Now we want to start changing the names of lines. And so the first thing we're going to do is we're going to say, all right, if I pick a point here, B, that's on a line, and now this is a line and not a segment, so this line, let's see if I can draw a line here, A and C, and B is somewhere on that line. And so you're going to go through and fill in a few details of this in a homework assignment by writing down the definitions of the line AC, what it means to be a point on the line AC, and what the definition is of the line AB. But without going through writing down every detail, the idea is that you say, okay, well, B is on this line somewhere. So it's either on this segment, or it's on this side of the segment, the A side of the segment, or it's on the C side of the segment. And wherever it is on the C side of that segment, knowing that B is on the C side of this segment, in the definition, that's saying that that C is on this segment. That's how we defined a line. And so we can say, all right, well, that makes C on the line AB by the definition of the line AB. So the way we've written that definition with this property or that property or the other property, those match up with the definitions of the line AC and the line AB. And then this theorem 5, technically you have done it with a new point B and the second letter in the name of the line. So when you name this line, you name it the line AC. And so we'd like to be able to say, oh, you know what, if I've got a new point, I'd like to be able to switch it with the first point that I use in that name. And so you're like, oh, do I have to do this over again? And the answer is no, I don't have to do this over again, which is why this is called a corollary instead of a new theorem. I get to use this theorem over again. So how do I do that? Well, theorem 1, which we proved 1a, we did not write out the proof of 1c, but you get to use theorems, all of the parts of theorem 1, even the ones that we didn't slow down and stop and prove. I have proved those and checked those. Those are really true. You can use things that are earlier in our list. So theorem 1c says if I write AC as a line, well, that's the same line as if I just switch the order of A and C in that name. And so what that does for me is it says, okay, well, if I've got a point that's on that line, and I have a theorem that says I can switch B with the name of the second point that's used in naming that line, and I want to switch B with A, well, I can just rewrite AC so that A is the second letter, and then now I can use theorem 5. So I can't use theorem 5 when A is the first letter, but if I use theorem 1 to switch the order, then I can use theorem 5 to switch A and B. And of course I can use theorem 1 to switch this back to being BC. So a lot of how we're going to prove things, a lot of the way I've set these theorems up, is that it's kind of like a puzzle. Oh, well, I can use theorem 5 here, and I can't use it where I want it, but if I do theorem 1 first, then I can do theorem 5, and then I can use theorem 1 to get it back where I wanted it. So that's part of what we do when we're proving theorems, is we're being very careful about those steps. All right, theorem 6 now says, all right, we've gotten close. What I want to say next is that if I have 4 points that have any order, W, X, Y, Z, any order at all, that's the order for that particular naming, then I can name a line with any 2 of these. I can pick any 2 of these to name a line, and I can pick another point and say it is on the line given by those 2. So Z is on the line named by W and X. And so this is another one where we're putting things together. So the first thing we do is we go back up and we use theorem 3, which is all about when you've got points in order on a line. And A and C say that these middle 2 points are on this segment between the first and the last. So that means I can say that X, or Y, is on the segment between the first and the last. So I can use theorem 3 and it will get me that X is on the WZ line. And then, so then we're kind of halfway there. I want Z to be on WX, and I've got X on WZ. And then I want to switch it up so that the line is named by Wx and the point is z, and I say, oh, I just proved some theorems about switching a point that's on a line with the named point on the line. Which one, is it 5 or is it 5.1 that fits this? Well, here I've got z. I would like to switch x, that's my point, and z, that's the second part of the name. Theorem 5 switches the point and the second part of the name, so I get to use Theorem 5. All right, we're done. I can get z to be on that line. So one of your homework problems asks you to do a couple more of these. So I picked like 3 random letters out of W, X, Y, Z and said, okay, how are you going to get these together? And you're going to do it by using Theorem 3, which will let you either say that one of these middle ones is on the line with the outer two, or that one of these middle ones is on the line with the two it's right between. Okay, so you're going to get Theorem 3 to pick out the 3 point names that you want to use, and you're going to use Theorem 5 and maybe Theorem 1 to get things in the order so that you have the right 2 points naming the line and the right point being an element of that line.